Good morning, grade 7s, and welcome to another day of learning with WorksheetCloud. For those of you that have been here before, you know the drill, you know what's expected. For those of you that are new to learning with WorksheetCloud this week, welcome. I look forward to teaching you new things. My name is Mrs. Hall, and today we are going to be looking at acids, bases, and neutrals. This is a two-part lesson, so please watch tomorrow for the follow-on of lesson 2. For today's lesson objectives, grade 7s, I want you to find out or know about the difference between an acid and a base. I want you to know strong and weak acids, strong and weak bases. I want you to know and understand what an alkali is, as well as what neutralization is. And then at the end, every now and again, I like to make sure you've understood everything I've taught you. So there's a little quiz to keep you on your toes. Let's get started. Why is it so important that we know about acids and bases? First of all, we want to know why our teeth look like this by drinking fizzy cool drinks. And we also want to know about the importance of acids and bases in our bodies and how we can neutralize the acids and bases in our body. And then, grade 7s, do you know that your dad and even maybe your mom, if she enjoys working on the pool, keeps the pH in your pool at a perfect 7.2. Why is that important? This week, if you're lucky enough to have a pool at home, I want you to work with your mom and dad and go and test the pH of the pool and understand the acidity and alkalinity of a pool. And that is for your own research. For those of you that aren't lucky enough to have a pool at home, I'm pretty sure you've swum in a pool sometime in this beautiful climate that we live in South Africa. So still do the research and understand how a pool is always kept this beautiful blue color. Let's start with what is an acid. As you know, acids are a group of chemicals, and acids are found in household items such as food, drink, and even beauty and skincare products. Okay, so we get everyday acids and we get laboratory acids as well. What are the properties of acids? First of all, let's understand and recap what a property is. A property is a description of how a substance behaves and its characteristics. The properties of acids are as follows. They are substances with a sour taste, and they also feel very rough on the skin. So when you bite into that orange, sometimes it has a very sour taste, and when you squeeze the orange juice out on your hands or lemon juice, it has a very rough feel on your skin. Examples of everyday common acids that we use in our homes would be sulfuric acid. We use it in our car batteries. Hydrochloric acid, we all have it in our stomach. Carbonic acid is found in these lovely fizzy cold drinks over here. Lactic acid, we find it in sour milk. Citric acid in oranges and lemons, as well as acetic acid, which is the vinegar you have on your fish and chips. What are natural acids? Natural acids are the natural acids found in the kitchen. For this reason, they are also called household acids. One very well-known household acid is acetic acid. Vinegar is a mixture of a small amount of acetic acid dissolved in some water. So vinegar is a solution of acetic acid in water. Ascorbic acid, which is a vitamin C. We're all hopefully taking this right now during this time of lockdown because it's supposed to boost our immune system and keep us strong and help us fight the coronavirus. So ascorbic acid is a natural water-soluble vitamin. vitamin C. Ascorbic acid is a potent reducing and antioxidant agent that functions in fighting bacterial infections, in detoxifying reactions, and in the formation of collagen in fibrous tissues, in your teeth, your bones, your connective tissue, your skin, and your capillaries. I hope you're all taking your vitamin C every day, grade 7s. Right, I think you all got a fright when you saw that photograph of that happy smile right at the beginning. What happens when you drink Coke? What happens when you drink physical drink that has carbonic acid in it? Okay, that's what your teeth should look like. And that's what your teeth look like after being exposed to Coke for long periods of time. Yes, I hope I'm scaring you. I really do. Says me, who loves myself a glass of Coke Zero every now and again, but I need to teach you this stuff. So the sugar in the soda combines with the bacteria in your mouth to form acid, which attacks the teeth. So diet or sugar-free soda contains its own acid. Yes, even sugar-free. I like to think Coke Zero is fine, but it's not, which can also damage your teeth. Each attack lasts about 20 minutes and starts over with every sip of soda you take. So these ongoing acid attacks weaken your tooth enamel. And now I'm going to show you, I'll tell you later on in this lesson, why it's so important that you brush your teeth every day. Right, although most acids are harmless, some are actually quite harmful. For example, some acids eat through plastic, through clothing, through skin, and even corrode metal. There you go, there's a sign, do not touch, with gloves on and specific gear to prevent you from harmful acids. Sometimes these properties of strong acids, however, can also be useful to us. For example, hydrochloric acid in our stomach helps us to digest our food. There you have it. That's our stomach. And over there you will find all of your stomach acids which come out and help you to digest your food. So we have acid inside of us, and the human stomach produces hydrochloric acid, and that's a chemical formula commonly known as stomach acid. Stomach acid is made when you eat something. But when a person eats something requiring the stomach to work extra hard, say for example a pizza, which we all love, the stomach may generate excess hydrochloric acid. And sometimes we get heartburn. It's a horrible feeling, and it goes up through our stomach into our throats. Have you ever experienced that before? Right, what is a strong acid? A strong acid are those that are found in the laboratory or a car battery, and they are very dangerous. So that means they are too dangerous to taste or touch, and that is why your teachers are so strict with you in the science lab, grade 7s. Here's some examples: nitric acid, hydrochloric acid, as well as sulfuric acid. These acids are said to be corrosive, as they can damage other materials by wearing them away. They are very strong acids. And then we have to ask ourselves the question, why must strong acids always be handled very carefully? Because they are corrosive and they will burn us. What is a base? A base is the opposite of an acid. The properties: bases generally taste bitter. Not that you want to taste a bar of soap, but generally they taste bitter, and they have a very soapy feel. So when you feel them between your hands, it gives a slimy feel, kind of. Bases are found in household items such as soaps, baking soda, and antacids like Eno. And this is an important part of our lesson when I discuss it further on in the next couple of slides. Some examples of bases in our homes: ammonia has household cleaners like Handy Andy, sodium hydroxide, which is our drain and our oven cleaners, sodium bicarbonate, which is baking soda, and then I put in some chemical formulas because you're going to start learning about these chemical formulas next year in grade 8. Potassium hydroxide, and you will understand these chemical formulas once we start the periodic table in the next few days. Okay, that is a liquid soap. Magnesium hydroxide, which is known as MOM, milk of magnesia, and aluminium hydroxide, which is also an antacid, sorry. Now, you often get confused between a base and an alkali, and some people refer to them as the same thing. But an alkali is different, grade 7. An alkali is a base that is able to dissolve in water. Okay, so your everyday bases that can dissolve in water. It is safe to handle these alkalis, which can feel quite soapy on our skins. These alkalis are known as weak alkalis. Some alkalis, like those in the laboratory or in cleaning materials, such as toilet cleaner, are too dangerous to touch. And why is that? Because these alkalis are said to be caustic. Now remember, acids are corrosive. They burn through metals, okay? Now, alkalis are caustic because they can burn your skin and damage other materials. They are strong alkalis. Why must strong alkalis always be handled very carefully? Because it will burn through your skin, grade 7s. Now, take a look at these pictures over here and think about it. Just put them up. Is this an acid or a base? Just from what I've already been teaching you. Glass of fizzy cool drink, it's an acid. Right, vinegar, it's an acid. And over here, we have our bases. Yes, toothpaste is a base, milk is a base, and Eno is a base. It's the opposite of an acid. And we're going to speak about how they work and neutralize the acids in our body. Right, so most antacids contain an alkali, that is a base that can dissolve in water. And this is usually calcium carbonate, magnesium hydroxide, or aluminium hydroxide, or we also call it sodium bicarbonate. And these antacids neutralize the acid in our bodies. How does this happen? They work together and they react with the acid in our body. So it works by reacting with the acid in what we call a neutralization reaction. So if we have acid reflux, we take a special medicine like Enos or Malox, and the medicine works by reacting with the acid to neutralize its pH and therefore reduce the acidity. The medicine is administered orally, taken through our mouths, and used to counter the symptoms of acid reflux or heartburn. It neutralizes the acid in the digestive system. So here we look at neutralization, and here we have our pH scale, and we're going to go into this in a lot more detail tomorrow. We're going to speak about chemical indicators, etc., etc. But for now, let's just do a little bit of a basic recap here. So neutralization is a chemical reaction when you mix an acid and an alkali. So on our pH scale over here, this is showing our acids, okay? Our neutral is sitting at 7, and anything to the right of the neutral is considered a base. To the left of the neutral is considered an acid. And obviously the stronger acids are here, and the stronger bases are here. And then our acids obviously get weaker, as do our bases. A neutralization reaction occurs when an acid and an alkali are combined in proper proportions that result in a product with no acidity or alkalinity. They cancel one another out and produce a product that has a neutral pH over here. Perfect neutral pH of your pool would be about 7.2, and that's your homework for this week. So, yes, me and my funnies, took an acid-base chemistry test today, and it was pretty basic. Yes, grade 7s, we are going to do a little quiz now, and I hope it's going to be pretty basic for you, and you're going to get it like this. Quick. Right, what do you know? What can you remember from this lesson? Question 1. This is the symbol for which hazard. Take a look at what's happening, right? It looks like it's going to burn through something or corrode something. So this is the symbol for which hazard. Is it an irritant? Is it corrosive? Is it flammable? Is it poisonous? What would your choice be? And I want you to either write it down on a piece of paper, or if you're feeling like you need to get rid of some negative energy, just shout it out at me, shout it at the screen. Get rid of that negative energy by shouting out the answer at me if need be. I know we all sometimes need a release, so use this opportunity to shout out the answer, because I can't hear you anyway. That's the bonus of this online teaching. Right, well, for me anyway. What would you think your answer would be, grade 7? I would go with corrosive. Yes. So vinegar, fizzy drinks, and tea, yes, I'm including tea in this, are all what? Is it A, an acid, B, an alkali, C, a neutral, or D, toxic? What's your answer? I'm going to go with A for acid. Yes, green lights. A substance that is corrosive and has a pH lower than 7 is classified as a what? Remember I did that quick little pH scale with you, and 7 was the neutral, lower than 7. So going to the left, what would it be considered as? A, a neutral, B, an alkali, C, a base, or D, an acid. What is your answer? I would go with D. It is an acid. If the right amount of acid is added to the right amount of alkali, what happens? A, acidification. B, alkalination. I need some water. C, neutralization. Or D, explosion. What's your answer? I'm going to go with C, neutralization. A substance with a pH greater than 7 is classified as a what? So to the right of the pH scale, going this way, we had our A, alkalis, B, our acids, C, our explosives, or D, our neutrals. Right? Remember, an alkali is a base that dissolves in water, so a pH greater than 7 is classified as an alkali. Imagine how funny it would be if I clicked on one of these and a red light came up and your teacher gets it wrong. Oh, that would be a bit of a moment for me. Question number 6. What must you do if a substance with this symbol gets on your hand? Okay, this is just general common knowledge. What would you do if a substance with this symbol got on your hand? Let's hope it never does, because you shouldn't be fooling around in a science laboratory in school. A, nothing will happen. B, you'll just wipe it off. C, you will lick your hand. Or D, you will wash them with plenty of water. What do you think you would do? I think I would go with D. I would wash them with plenty of water. Question 8. I think I missed question 7 there. Okay, let's carry on. Acids that are drunk or found in foods are what type of acid? Is it a corrosive acid, a strong acid, a diluted or weaker acid, or D, a poisonous acid? I would go with dilutes. Question 9. Citric acid is found in what? Grade 7. Citric acid, we spoke about it right in the beginning. Is it A, vinegar, B, tea, C, fizzy drinks, or D, lemons? Citric, citrus fruit, lemons. Question 10. Ascorbic acid is also called A, tea, B, vitamin C, C, a fizzy drink, or D, vinegar? What would you go with? And I told you it was very important that you're taking this right now during this lockdown, building up your immune system. It is vitamin C. Grade 7s, thank you for watching this lesson. I hope you enjoyed it. I hope you learned something new. Tomorrow we carry on with lesson 2 of acids and bases. You can download worksheet 1 on acids and bases as well as the memo. If you can't answer all the questions in worksheet 1, rest assured you will be able to by tomorrow's end of lesson 2. Enjoy the day, have a great afternoon, and be kind to yourselves and to your family. Take care, grade 7s.